Welcome back, everyone. Welcome back to my math channel online again today. In this video today, I would like to show you the lesson in the composite function and how we find the domain, the range, and we want to know whether or not does the composite function we create exist or not. So this is the topic for the lesson today. And let's get started right into it. So on the board, I have question 1 here. Given the g of x function equal 1 minus x, and given the f of x equal minus 4x minus 3, find the g of f of x if it exists and why. So let's first identify which one is the outer function, or we call it output function, and which one is the inner function, or we call it input function. So the g of x here is the outer function. So this is the outer function. And the f of x here is the inner function. So if you want to find, but let's first talk about the domain first. So the domain of f of x here is the linear function. So for the f of x, right, we're going to state the domain of f of x. So domain of f of x is on x such that x belongs to the real number. And this domain of f of x here will become a range of the inner function. So if I write the function in this way, you will see obviously you will see this f of x is the range and turn out to be a domain of g of x. So the domain of f of x here is on real number. What about the domain of g of x? The domain of the outer function is also on real number. So we don't see any problem, right? The domain of the g of x here also on the x, and x belong to the real number. So both functions are linear, and there isn't any restriction in here. So to find the composite function g of f of x, we will put the function f of x here into the function g of x. So we follow the expression of the function g of x. So g of f of x will be equal, we follow the expression here, which is 1 minus the x of the g. Now, remember, this is the x, right? This is the domain of g. Now will become the whole function f of x. So the x of g now is f of x. So we're going to substitute this x by the function f of x, because this is the x of the g. And the x of the g here, you can see that it stands for f of x. So we're going to substitute the x of g as the function f of x. So the function f of x is minus 4x, and make sure you put in bracket, minus 3. So basically, g of f of x, you can write this way or you can write this way, it doesn't matter. This will become 1 minus, minus with minus become plus 4x, minus with multiplied with minus here become plus 3. So the answer for the composite function g of f of x will be equal 4x, 3 plus 1 is 4. And now, after we're done with the composite function, we can state the domain and range of our new composite function. So the domain for our composite function is x, a set of x such that x belongs to real number, because this is the linear function as well. There's no restriction. And the range will also a set of y such that y belong to the real number. So that's how we find the composite function g of f of x. So in summary, if you want to find the composite function, you just make sure you identify the outer function and follow the expression of the outer function. Substitute the x of the outer function by the new function. So then you can combine them and become a composite function. Okay, so I hope you can follow this. Now, question 2 is a little bit tricky, right, in terms of domain and range, but let's see. So question 2 asks us to find f of g of x. So again, this is the outer function and g of x is the inner function. So let's realize that. Now, let's find out the domain of f of x. So the domain of f of x here is 9 minus x squared. Now this is the radical function. So therefore, we not allow for any number inside the square root become a negative. So 9 minus x squared have to be bigger equal 0. It means solving like the same you solve equation, separate the letter and the number. On the other side, we have minus x squared bigger equal minus 9. Now at this point, because they are both negative, so you want to change the sign of x, the unknown letter become a positive. And just like the balance equation, whatever you do to the left, you have to do to the right, except here is the comparison, not a balance side. So we have to be careful when we change this side become a positive, you have to twist this side, twist this, and twist on 3 of them. On 3 of action do at one time. So this become positive x squared, but this side will be turned opposite, less than or equal, and this become 9, positive. So that's the only difference in terms of solving the equation or inequality. To see how we solve the inequality. Solve inequality, if you never can solve for a negative unknown, and you want to change this become a positive, then you have to change this left side, you have to change this inequality side to the opposite, and you also change the last number. So by doing that, you're not making an error for the side. So at this point, you know that to solve for x, you have to take the square root both sides. And when you take the square root both sides, just like you solve for the equation, you will end it up with two number, adding, subtract. So x squared will be less than or equal and subtract 3. So what does that mean? This means that minus 3 have to be less than or equal x, and x has to be less than or equal 3. So this is the domain of f of x. This is the domain of f of x. So now we look at the domain of g of x. So what is domain of g of x? The domain of g of x here is on real number, because this is the linear, right? So on real number. So there is no restriction for g of x. However, there is a restriction for the outer function, but there are no restriction for the inner function. So what does that tell us? This will tell us that if we want to put the function g of x into the function f of x, then we have to restrict the domain of g of x so that it can fit into the domain of f of x. So let's find out. So first, let's find out the composite function of f of g of x first. F of g of x. So this composite function will base on the outer is the f. So we're going to follow the expression of the outer function, which is square root of 9 minus our x squared will be substituted by the function g of x. So this will be 3x and squared. So this equivalent to 9 minus 9x squared. Now at this point, we can factor out the 9 outside as a factor, and inside will be 1 minus x squared. So then we can take out the 9 outside. So this will become 3. Square root of 9 is 3 outside, and inside we left with this. So this is the composite function f of g of x. Now, at this point, we have to restrict, we have to find the domain of the new composite function. So the domain of our f of g of x will be a set of x such that, okay, if you zone outside, let me zone outside for you first. 1 minus x squared got to be bigger equal 0. So minus x squared have to be bigger equal minus 1. So twist on the side together will be x squared have to be less than equal less and subtract 1. So the domain of the new function will be minus 1 less than or equal x less than or equal positive 1. So this is the domain of the new function, which is minus 1 less than or equal x less than or equal 1. So now let me show you the picture of this so that you can see how it looks like. So let me erase this here so we can. Okay, so if we draw this picture so that we can see it more visualized. So let's say this is minus 1, minus 2, minus 3. 1, 2, 3. So this is minus 3 and this is 3. So first, the outer function will have, this is the half of circle, right? That's the half of circle with the radius of 3. So 1, 2, 3. And let me mark them equally a little bit. So, okay, so 1, 2, 3. So this is the function f of x. This is the outer function. Yes. This is the shape of the outer function. This is the half circle. And this is y equal 3. So now when we do and you see that the domain of this half circle restrict between -3 less than x, between this domain, -3 less than x less than 3. Now, when we do the g of x, because the domain of g of x is very large, but because we put in the f of x, so now the domain of the new g of x here is become small, smaller than the outer function. So therefore, our f of g of x turned out to be -1 and 1. So turn out to be, and we multiply with 3, and therefore it looks something like this. The y is multiplied with 3. So the x is just restrict between -1 and 1, but the y, because we multiply with the 3 here, so it go up there. And it turned out this is a function f of g of x. So we suppose to put the g of x inside the function g of x inside the function f of x. And when we do this, if we don't restrict the domain of g of x, right? So the domain of g of x is very large, right? From negative infinity to positive infinity. But because we put it inside, so now the domain of g of x were restricted by between -1 and 1, which is, yes, it can fit it inside this outer domain. So you can say, yes, it exists for, and the range of g of x, right? The range of g of x, instead of from negative to positive infinity all the way from here to here, but now we have to restrict is a set of y such that y less than, no, such that minus, such that 0 less than y less than or equal 3. So that is the range of g of x have to be restricted so that this function exists, because down here you don't see any function, right? From the y equals 0 here, down here you don't see any function. So therefore the range of g of x will be restricted like this in order to fit in this picture. Okay, so this is the number 2 question. Now let's solve the same question, but we will, this time we'll do the other way around. We'll find the g of f of x instead of f of g of x and see what happens. So let me erase this. Now we will find the opposite, right? We will do the opposite, see what the picture looks like. So, find, let's do this, our next question. So this is A, and let's say this is B. Find g of f of x. Instead of f of g of x, now we find g of f. I can see what happened. So we know that domain of the f of x, let's state it again, is x such that minus 3 less than or equal x less than or equal 3, right? We just did it the same question. So that is the domain of f of x. Now domain of g of x will be on real number. Same thing, right? On real number. Now let's do g of f of x. So now we will find the composite function g of f of x. So this time you can see the function f of x is inner function and g is the outer function. So if g is the outer function, we follow the expression of the g of x here, right? Which is equal 3 times with the x. But what is the x? We will substitute by function f of x. So now we substitute that, we will get something like this. So now we will say, so this is the new composite function. So now we have to find domain for our new composite function. What is the domain of our new composite function? It's exactly the same like this domain. Then nothing changed, right? The 9 minus x squared have to be bigger or equal 0. And after we solve, we get exactly the same. So the domain for this function, for the new g of f of x, will be the same, which is minus 3 less than or equal x, less than or equal 3. Same thing, exactly the same. Now, let's figure out how we must get this function and see what's going on. What is the difference between if we do reverse, what it look like? So again, this will be minus 1, minus 2, minus 3. And 1, 2, 3. And up here will be 1, 2, 3. Okay, so now if we get the function out of the inner function, let's see how it look like. This is the function f of x, right? F of x. Now we're going to get the function, new function g of f of x. And our new function is the same radius, right? The radius between any y of 0, you multiply with 3, still 0. So the point is still here. 3 here, multiply with 3 here, still 0. Sorry, 0 times with the y here is 0, right? 0 times 3 is still 0. 0 times 3 is still 0. Except this number 3 here times 3 will become 9. So 3, 4, 5, 6, 7, 8, 9. Let's say up top here. So our new function, the composite function now have a shape look like this. So this is the function of new function g of f of x. And let me draw a little bit more decent, look like a circle rather than the top pyramid like that. Okay, so that's how it looked like for our new function g of f of x. So this time the g of f of x function look bigger than the function f of x. And let me state the domain of our new function. And actually the domain of our new function is already stated here. So what about the range? The range of the function g of f of x will be g of f of x will be a set of y such that 0 less than or equal y less than or equal 9. So that's the new ring for our, let me write down here, y such that 0 less than equal y less than equal 9. That's the range for the new function. So from these two examples, you will see it's a little bit complex in terms of domain and range for the composite function. Okay, so as I keep going for the another new example, because I will not just end the video in these two examples here, but I will keep going with this lesson for a few more examples. As I get going with a few more examples, you will see the picture more clearly. So basically, let me summarize this one. This one only exists if we restrict the range of g of x instead of on real number, right? The domain of g of x before is on real number. And the range is on real number as well. But now we have to restrict the range of g of x from 0 less than y less than equal 3. If we want to find the composite function of this. And because the outer function have a larger domain, so it turned out if we try to put the big function here into this outer function, then under net of this outer function, the new composite function will be shrinking like this, will be smaller like this. And this is the shape of it. So it can be done, but yes, it exists only if we restrict the domain and the range of the function g of x within this domain and range we stated here. The domain have to be between -1 and 1, and the range have to be 0 less than equal y less than equal 3. Then we can create the composite function in this situation. So the next one, you will see obviously the domain of function outside is larger, and it can contain the new function g of f of x function. The domain of the function g of x is large, between -3 is on real number. However, when we do the composite, it will have a shape like this. And this the function look like it outside the g of f of x. So this is the function f of x. We put in inside the function g of x. We create the new function g of f of x look like this shape. So that's the idea. And this one is, again, we restrict the domain of the inner function, and we restrict and we find the domain of our new function. We state the domain of our new composite function after we're done. So this is the composite lesson. It seemed to be a little bit complicated in terms of domain and range, but as we get going, you will see that it's not so bad if I show you other example. So thank you for watching, and bye for now.